Oh, why hello, Algebra 2. We're right back at it. We got some polynomial stuff going on again. We've got Poly3, factoring. Oh, it's your guys' favorite thing in the world. Factoring. We're back to factoring. Instead of quadratic factoring this time, though, it's going to be higher order polynomial factoring. Not that quadratic factoring won't come into play. We're going to see that actually right away, but it's going to be a little different. Just like before, we're going to solve and find all roots. This means we're going to find this time. So before with quadratic factoring, we didn't. There are ways to do imaginary factoring or getting imaginary solutions with factoring. We didn't do those, but with polynomial factoring, we may and we will get some imaginary solutions. So let's go ahead and start this out. I got kind of 4 different ways we're going to talk about. I'm going to do 2 examples of each, and you're going to do 2 examples and check them. Then we'll do some practice. So let's go ahead and get going. We've got greatest common factor to quadratic. So this is the style, right? The style right here, greatest common factor to quadratic. Just like before, the first thing you need to do is check for greatest common factors. And if we do this right here, I know it's a little goofy here. We got x cubed plus x squared minus 2x. Well, I heard that when I said that out loud. We've got something in there. It's not a constant. It's not a coefficient this time. It's not a numerical value. That's our greatest common factor. But you can have variable greatest common factors. I'm going to divide each of these by x and pull it out front. X squared plus x minus 2 equals 0. And then now we look inside. Hey, this looks really familiar right in there. That looks a lot like quadratic factoring. And because it is, what multiplies to -2 but adds to +1? X times x plus 2 times x minus 1 equals 0. Yeah. So we just factored. We pulled the greatest common factor out. It happened to be a variable, and we just used quadratic factoring. That's why I called it greatest common factor to quadratic. Now we need to solve, though, also set every factor. There are 3 factors. There are 3 solutions because there is a 3 right there. Look to see what the biggest exponent is on your variable. That's how many solutions you will have. They might not all be real, but that's how many solutions or roots you will have. We'll set each individual factor equal to 0. Remember, x is a factor. X equals 0. Well, yeah, just x equals 0. That's one of the things we could have. We could set x plus 2 equal to 0. So x would equal -2. X minus 1 equals 0. So x would equal 1. Our 3 solutions are 0, -2, and 1. Okay, you've seen that one time. Let's see it a second time. Same thing. We're going to pull a greatest common factor out. Actually, I'm going to turn the brightness down a little bit here. There we go. I've got it. We're going to look at greatest common factor. I've got x cubed minus x squared minus 6x. Once again, they've all got an x in common. X times x squared minus x minus 6 equals 0. You can also see how this relates to the whole multiplication of polynomials thing. It's just kind of the inverse of that, right? Because if I distributed this x back through, x times x squared is x cubed, x times -x is -x squared, x times -6 is -6x. So we see how these things are working together, and that's why they're in the same unit. Now we look, we've got the x out front. That's your just kind of hanging out there. What multiplies to -6 but adds to -1? X times x minus 3 times x plus 2 equals 0. And set your individual factors equal to 0 and solve. X equals 0, that comes from the x out front. X minus 3 equals 0, so x equals 3. Then x plus 2 equals 0, so x equals -2. Now, if you see this already, if you already like, whoa, I can see from here, when we get to that factored form, then it's going to be 3 and -2 and 0. That's fine. I just wanted to remind you of where those actually come from. With that said, you've got numbers 3 and 4 as your turn. Give them a shot. Come on back. Check your answers. All right. Go ahead and check your answers there for numbers 3 and 4. Those are your turn. So we pull out an x as the greatest common factor for both 3 and 4, and then we do some basic factoring there. We get solutions for number 3 as 0, -1, and 4.
And for number 4 is 0, 2, and 3. All right, with that said, the second style I'm getting to, we're going to talk about this second style right here, and it is going to be...
That's called higher order quadratic factoring. Now, this looks intimidating. I understand. This looks a little intimidating, but let's go ahead and take it and just break this down. Had this been x squared minus 12x plus 35, you would know how to do it. What multiplies to 35 but adds to negative 12? You tell me negative 5 and negative 7. It's going to be the same thing. What has to happen is this exponent has to be twice as big as this exponent. Because if you remember, x squared is x to the 4th. In other words, what we can do is we can call this x squared minus 7 times x squared minus 5 equals 0. Oh, that's interesting. That's interesting. It's the same thing. It's quadratic factoring, but it's a polynomial because we're looking for 4 solutions because of that biggest exponent there. And will we get 4 solutions? Yeah, we'll even get 4 real ones because I can set that. I can't factor that any further. I can't factor that second term any further, but I can solve for them because we just did that. X squared minus 7 equals 0. I can solve. I add 7 to both sides. X squared equals 7. Well, how do I solve for that? Take the square root of both sides. Square root. X equals plus or minus the square root of 7. This just gave me 2 solutions. Positive square root of 7, negative square root of 7. I need 2 more, and where am I going to find 2 more answers in here? Oh, here we go. X squared minus 5, set that equal to 0. Remember, we're using that 0 product property because if you multiply things together and you get 0, one of those things has got to be 0. We're just not sure which one, so we're going to figure all of them out. If I solve for x squared equals 5, square root both sides, x equals plus or minus, don't forget that, the square root of 5. So that's my third and fourth solution. I've got square root of 5 positive. Try that again. Square root of 5 positive and negative square root of 5. That gave me 4 solutions. So this is factored form up here. And had we been able to factor out more, we could have done that. We had factored form up there and then solutions down there. I'm going to try one more. Going to walk you through one more, then you're going to try 2. Well, this greatest exponent is twice this one. And the difference between this one and the first one, the higher order factoring versus greatest common factor, there's no greatest common factor between x to the 4th, negative 2x squared, and negative 35. If there was, I'd pull it out, but it wouldn't be a variable anyway in this case. Do the same thing. What multiplies to negative 35 adds to negative 2? Well, in this case, we're going to end up with x squared minus 7 times x squared plus 5. Yes, they look very similar, but there's a reason I chose this as our second example. For our first one, this again, there you go, factored form. Whoops, try that again. That is factored form. Set our first one, x squared minus 7 equal to 0. Well, just like before, it's going to end up being x equals plus or minus square root of 7. That gives us 2 of our roots. We need to find 2 more. We've got x squared plus 5 equals 0. Well, x squared equals negative 5. Oh, I'm going to get some imaginary stuff. If I square root both sides, you get x equals plus or minus I times the square root of 5. In other words, if I was to graph this, if you put this left side into Desmos, the x to the 4th minus 2x squared minus 35, if you put that into Desmos without the equals 0 part, you're going to see that it touches the x-axis in 2 spots. Positive and negative square root of 7. And then we've got these 2 imaginary ones where it will not touch. This x to the 4th, this 4th order polynomial will only touch the x-axis twice. But we found all the roots. We've factored and found the roots. Now it's your turn. Give these 2 a shot, numbers 7 and 8, using the same thing, the same style that we've been doing. Give it a shot. All right, now that you're back, you should have number 7 and 8 done. we found that the factored form for number 7 was x squared plus 2 times x squared plus 9 equals 0. That's awful close to being something we could have factored again. That x squared plus 9 had it been x squared minus 9, we could have used the difference of 2 squares, but it's not. You might see that. You might see that. That's okay though. And when we solve for each of those factors, we get square root, I squared root 2 plus or minus I squared root 2 and plus or minus 3i. We need to have 4 solutions, but it's interesting. Those are 4 imaginary solutions. That function would never touch the x-axis. If we look at number 8, we end up with x squared plus 4 times x squared plus 9 equals 0. We solve both of those factors. We get plus and minus 2i and plus and minus 3i for our 4 solutions or 4 roots, but none of them touch the x-axis. Interesting, but that's okay. That's okay. We are coming up on one of my favorite things. And one of the reasons that when we were doing multiplying polynomials, one of the reasons I was so emphatic about doing distribution when you're multiplying is this right here. Factoring by grouping. This essentially is reverse distribution. I'm actually going to do number 10 first. I'm going to show you number 10 first. When you have 4 terms like this, first you got to look for a greatest common factor, and x cubed plus x squared plus 4x plus 4 has none. You cannot pull the same thing out of all 4 terms. Just one, then it doesn't matter, right? But what we're going to do, well, we have 4 terms like this. I'm going to split them up into the first 2 terms and the second 2 terms. I'm going to look at them independently. I'm going to look at x cubed plus x squared. Is there a greatest common factor between x cubed and x squared? Well, yeah, x squared. What if I did this? I'm going to call this x squared times x plus 1, right? This is taking the greatest common factor out. If I would have multiplied this back through, I'd have x squared times x, which is x cubed, plus 1 times x squared, which is x squared. Okay, just make sure I did this right. Okay. Now look at the last 2 terms. I've got 4x plus 4. What's the greatest common factor between 4x and 4? Hopefully you're saying, oh, Mr. Brayman, it's 4. I'd say, yeah. So here's what I'm going to do. I'm going to say 4 times x plus 1. Well, that's kind of interesting. That's kind of interesting. Huh. Because let's just kind of take a step back here. What if I was multiplying? What if I was multiplying x squared plus 4 times x plus 1? If I was doing the distribution way, I'd have x squared times all of this. In other words, that'd be x squared times x plus 1. And then plus 4 times x plus 1. 4 times x plus 1. Interesting. Interesting. So instead of multiplying it out, we're going the opposite way. This is exactly what we have, but instead of keeping it that way, instead of multiplying it out, we're trying to group it back together. We're trying to actually bring it back to this. So you notice how these are the same. Those are the same factors. I'm going to group these 2 together and call this x squared plus 4 times x plus 1 equals 0. I look through here, x squared plus 4 and x plus 1 cannot be simplified any further. So I've got my factored form. I'm going to solve the same way. If I take this right here, x squared plus 4, I'd have x squared plus 4 equals 0, x squared equals negative 4, and x equals plus or minus 2i. So those are 2 of my solutions. And remember, we're trying to get 3 roots here. 3 roots here. And the third one comes from x plus 1. X plus 1 equals 0, so x equals negative 1. Those are my 3 roots. Those are my 3 roots. I love this stuff, man. I really enjoy this. I really enjoy this. Okay. Let's try this one more time. We're going to do one more. We're going to come back to number 9 now. I'm going to separate the first 2 terms and the second 2 terms. I'm going to look at them independently. I'm going to look at x cubed minus 3x squared first. And I see that they both have in common my greatest common factor of x squared. So this becomes x squared times x minus 3. And knowing what I know now after that description, I know to make this work, in here has to be x minus 3. If it's not x minus 3, I can't group those things back together. And then I got a real problem. So let's see what happens. If I want to get to x minus 3, well, what times x gives me negative 3x? Well, that'd be negative 3. And then let's double check here. What's negative 3 times negative 3? That's my positive 9. That's one of the big keys. These two have to be the same. That factor has to be the same in order to do the grouping, because now we're going to group these two together and call this x squared minus 3 times x minus 3 equals 0. We check in here. X squared minus 3 cannot be factored any further, but it can be solved. X minus 3, that's all we got there. This is factored form. This is factored form. And now I'm going to solve. I need to find 3 solutions. They might be real. They might not be real. We'll find out in a second here. I'll set my first factor equal to 0 and solve. X squared minus 3 equals 0. So x squared equals 3. Take the square root of both sides. X equals plus and minus the square root of 3. Okay, there's 2 of my solutions right there. I'll find my third root by setting my second factor equal to 0. X minus 3 equals 0. X equals 3. That's, again, using that zero product property. Okay. This is one of my favorites. This is one of my favorites because we just got done doing that distribution and now we're using it. Again, we just got done doing quadratics and we were using them again. Well, not in this one, but the ones up above. With that said, try numbers 11 and 12 on your own, then come back and give them a check. All right, now that we're back, hopefully you've checking numbers 11 and 12 here. We have x cubed minus x squared plus 4x minus 4 equals 0. That factors to x squared plus 4 times x minus 1 equals 0. Our solutions are plus and minus 2i and x equals 1. And for number 12, that factors to x squared plus 5 times x plus 4 equals 0, with our solutions being plus and minus I square root of 5 and negative 4. All right. We have exactly, well, it's kind of one factoring type. I mean, we're going to write it as 2, but it's really the same thing. And we're going to see why that is in just a second. Okay. What we're going to do is we're going to look at the sum and difference of cubes. But first, to understand that, what we need to do, what we're going to do first here is just kind of do a little table. And here I'm going to put this. I've got x squared, and x cubed. So I'm going to square in this column. I'm going to square things. So how do I? So I'm going to square to get to here, and I'm going to cube to get to here. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, and here's where things get interesting. X squared squared, you multiply the exponents, you get x to the 4th. X cubed squared is x to the 6th, and x to the 4th squared is x to the 8th. Ooh, interesting. Interesting. Let's take a look at our cubes now. 1 cubed, or 1 times 1 times 1, is 1. We have 2 cubed, 2 times 2 times 2. In other words, we're kind of doing like 2 times 4 here. It's another 2, so I end up with 8. Well, that's a bad 8. There we go. There we go. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. Oh, we're getting big real fast now. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. And 10 times 10 times 10 is 1,000. Remember, we're multiplying exponents here. So x squared cubed, in other words, this one down here, this is like x squared cubed, or x squared times x squared times x squared. This would give us x to the 6th. because we're multiplying exponents. X cubed is x to the 9th, and x to the 4th cubed is x to the 12th. So I'm just trying to show you that there might not just be x cubed. You might have difference of 2 cubes, but it might be cubes again, okay? So let's go ahead and look at this here. The sum of 2 cubes and the difference of 2 cubes. Let's leave that whole, think soap there at the end for now. I'm going to tell you that if you've got 2 cubes and sum is addition. Also, just as a reminder, always look for a GCF. But the sum means addition. In this case, sum means addition. Sum of 2 cubes. In other words, if I have 2 things that are cubed and they're added together, a cubed plus b cubed, this factors to a plus b times a squared minus ab plus b squared. We're going to see this in action. It's okay. We're going to see this in action, okay? The difference of 2 cubes, if you've got 2 things that are cubed with a subtraction sign, because that's what difference means, this factors to a minus b times a squared plus ab plus b squared. Now, are those patterns things you have to memorize? Not exactly, but there are ways to remember what they are. Think soap. Mr. Gubino taught me this one. Think soap, not like, A Christmas Story, eating the soap, stuff like that, bad words. Although you might be saying bad words about factoring. I don't know. We'll find out. But soap means, let's do this. We're going to do S, O, and AP. And what we're talking about is the signs in here. The signs. We're going to do this. They're the same. So you'll notice if it's a cubed plus b cubed, the first one is the same, a plus b. Just like down here, it's a minus b, so it's the same. And then the next sign is opposite. So in here, since this was a cubed plus b cubed, this next one is going to be opposite or minus ab. And since the bottom down here was difference of 2 cubes, I'm going to do some arrows here. Opposite would be plus ab. And the last one is AP. It's always, it's together. It's always, we'll do it like this. Always positive. Because you'll notice that no matter if it's sum or difference of 2 cubes, it's always positive with the b squared, plus b squared. Okay, here's what I'm going to do with that one. I'm going to do 13 and 15. Let's look at 13 real quick. I love this, by the way. I don't know if you can tell. Factor each and find all roots. A cubed plus b cubed. So this would be like x cubed, because that's what's being cubed. Here, let me get back to my regular weird green color. This is like x cubed plus, well, what cubed gives us 8? Looks like 2. You notice we're going to use some smaller numbers. Yeah, it's okay. So plus 2 cubed equals 0. In other words, a is x, b is 2. So in this case, what I would have is x plus 2, a plus b, times a squared, which is x squared, minus ab, minus x times 2, or minus 2x, plus b squared. Our b value is 2, so plus 4 equals 0. Now you might be looking at that second polynomial and saying, well, can I factor x squared minus 2x plus 4? And the answer is no. When you do difference of cubes or sum of 2 cubes, that second polynomial will never be factorable more than that. You can still solve it, which we're going to do, but it will not be factorable any further down. Now we got to find 3 roots. Well, our first one is pretty straightforward. X plus 2 equals 0. x equals -2. We found one. Now we got to find another. X squared minus 2x plus 4 equals 0. Well, how can we solve this one? Solving quadratics, it's like that's what we just did. Now, we can't solve by square root in this case because it's not just x squared and a value and a constant. Could we do completing the square? Yeah, that's actually what I'm going to do. Could we do quadratic formula? Yeah, because the quadratic formula is the one that works for all quadratics. Could we do factoring? No, because I just told you can't. It won't factor. There's nothing that multiplies to +4 and adds to -2 that are whole numbers. I'm going to do completing the square. I like, especially when I have an even value, an even coefficient to my x term, my middle term, I like completing the square. I think it's more efficient than the quadratic formula. So if I'm doing completing the square, I'm going to move my constant to the other side, x squared minus 2x plus some value equals -4 plus some value. And here, this divide this value by 2, so you get x minus 1 squared, adding +1 to both sides. X minus 1 squared equals -3. Now we got to square root both sides. Oh, I wrote poorly here. I'm going to run out of room a little bit. X minus 1 equals, plus or minus I root 3. Add 1 to both sides, and x equals 1 plus or minus I times the square root of 3. Oh, man. So there's two roots there, 1 root there. I found it all. This was our factored form here. These are our 3 solutions. Woo! Woo! That's some good work right there. Like I said, I'm going to do one more with you because I think number 15 is an interesting one. I know they're both addition, but just hang with me, okay? The subtraction we've seen, they're difference of 2 cubes. Let's take a look at this real quick. X cubed plus 1. I remember, again, if I have a cubed plus b cubed, that gives me a plus b times a squared minus ab plus b squared. So what are the things cubed? And the reason I'm going with 8 again, because 8x cubed is a cube. This is just like 2x cubed, because 2x times 2x times 2x is 8x cubed. So 8 is also a cube. That's why I love this. Plus, well, what cube gives us 1? Well, 1. I like that too. All right. So if I've got that, this is like a cubed plus b cubed. So the factored form is my a, which is 2x, plus my b, which is 1, times a squared. And this is where you got to be careful, because a lot of people right now are going, oh, it's 2x squared. But it's not. It's 2x in parentheses squared. This right here is like 2x squared because it's a squared, and a is 2x. 2x squared is 2x times 2x, which actually gives us 4x squared, minus a, which is 2x, times b, which is 1, so minus 2x, plus b squared. B is 1. 1 squared is still 1. This equals 0. Got to give you guys some room too. Whew, that is factored form right there. That is factored form right there. Okay, now we got to find the roots. Well, the first one, pretty straightforward. 2x plus 1 equals 0. 2x equals -1. X equals -½ Our next one, though, oh boy, we got some quadratic formula going on. I don't want to do completing the square for this one. That just looks like a mess. That's going to be fractions, and no. Let's do the quadratic formula. Remember, it's x equals -b plus or minus the square root of b squared minus 4ac all over 2a. I think I got that out of order, but In other words, we got our A, our B, and our C right here. We're going to say x equals negative b, so negative negative 2, plus or minus the square root of b squared, so negative 2 squared, minus 4 times a, which is 4, times c, which is 1, all over 2 times a. A, again, is 4. Got some simplifying here to do. Well, minus a negative, so this becomes 2. Let me give you kind of our in-between here. 2 plus or minus the square root of, well, negative 2 times negative 2 is positive 4. 4 minus 4 times 4 times 1, so 4 minus 16, I got negative 12, all divided by 8. And then I have to, oh man, there's just so many things we've done. Simplifying radicals. Well, I know we've got that negative, that's gonna be an I. We can break 12 down into 4 times 3. The square root of 4 is 2. Square root of 3 is just square root of 3 because we're not dealing with decimals. And so I end up with 2 plus or minus 2i root 3 divided by 8. And just like before, we said it'd be really nice if you could simplify this further, and we can. We're going to simplify because you've got like this and this here. This simplifies to 1 plus or minus I root 3 divided by 4, all divided by 4. Oh, that's a lot of work. That's a lot of work. But we have the tools. We've been working our way up to this right now. All right, I didn't ask you to do that on your turn. There might be 1 or 2 on the practice, but you know, we'll take a look here. Go ahead, try numbers 14 and 16, and then check your answers when you come back. And we're back. Holy cow. Let me go ahead and make this a little smaller so we can see both of them at the same time. So number 14, well, we end up here, factors to x minus 1 times x squared plus x plus 1 equals 0. We get x equals 1, and then I used the quadratic formula and found that x equals negative 1 plus or minus I root 3 divided by 2. And then in number 16, we have x cubed minus 64. In other words, x cubed minus 4 cubed, so x minus 4 times x squared plus 4x plus 16 equals 0. Our first one's pretty straightforward. X equals 4 from that first factor. Our second one, I like to use, again, like I was saying, when I have an even value, for my coefficient of b, I really like to use completing the square. So that's what I did. I completed the square and ended up with my last two solutions where x equals negative 2 plus or minus 2i root 3. Would you get the same thing if you did the quadratic formula? Yes, you would. With that said, I know that's a lot, and that's okay. We're going to practice. You keep asking questions. You keep trying. We'll take a look at things. Take care. Have a fantastic day.